Welcome to my Bitwise operators tutorial, and if you haven't seen my last video that basically explains how to read and write binary and hexadecimal numbers, I would highly recommend that you go watch it right now before continuing, because we use a lot of the basic concepts explained in my last video in this video. So basically, I'm going to explain to you guys before I start what even a bitwise operator is. Basically, what it is it's an operator, of course, that takes two binary values and applying some sort of pattern or whatever to it gives you a third value that is unique from these two values. So, I'm going to start by explaining the bitwise AND operator. And actually, before I start, I need to create some variables. So I'll just do like I don't know, 8 and 24, two numbers. So let's see. Okay, there we go. So this is the number 8 in binary, this is the number 24 in binary. So if we take these two numbers and apply the bitwise AND operator, what's this number? Well, basically the way the bitwise AND operator works is it basically says, okay, both of these numbers in the same column for number 1 and number 2 have to be 1s in order for this number to turn into a 1. So since these three numbers are zeros, I'm not going to deal with that. But in the fourth column, we see that one of the numbers is a 0, and one of the numbers is a 1. And because only one of them is 1 and one of them is a 0, this one stays as a 0. But in our next column, we can see that both of these are number 1s, so therefore this one changes to a number 1. And so they're number 1s for the rest of this, so I'm not going to deal with that. But if we are correct, then our output should be this number. And I've basically programmed it so that the output of our program is the bitwise form of the number 3. So, that was a lot to say, but let's run this program. And there we go. So we are correct. This number is equivalent to this number. So, yeah. Let's go to another bitwise operator. Just as interesting though. The bitwise OR operator. And this little character right here is like, I don't even know what it's called. It's like a vertical, I don't even know. It shares a key with the backslash character, but anyways, yeah, it's that. It's not like a number 1 or an L or anything. It's that character. But let's change this back to a 0. I'm going to use the same number as 8 and 24, but basically now what the bitwise OR operator does is it instead of requiring both numbers in the same column to be 1s, it only requires 1 to be 1. So these three are 0s, so I'm not going to deal with that. But over here we can see that there is a 1 and a 0. But since one of these is a 1, this one changes to 1. So now what if both of them are 1s? Well, since only one of them has to be a 1, this one is also a 1. It doesn't matter if both of them are 1s. And again, the rest of them are 0s, so I'm not going to deal with that. So if we are correct, and if I calculated this right, this should be our output. So let's run our program. And here we go. 0, 0, 0, 1, 1, 0, 0, 0. And that is equivalent to this. So, yay, once again, we're correct. So I have one more bitwise operator for you guys before I take a quick break, and that is the bitwise, I don't even know how it's pronounced. It's like XOR, XOR, I don't know. But basically it's similar to the bitwise OR, except if both numbers are 1s, it stays as a 0. So basically what's required for the bottom numbers to change to 1s is only one of these numbers has to be a 1. So basically right here, 1's a 0 and 1 is a 1, so this one changes to a 1. But in the next column, since both of these are 1s, this one stays as a 0. So this should be our output. Let's test it. And 5 hours later. Okay, here we go. 0, 0, 0, 1, 0, 0, 0, 0. And that is equivalent to this. And once again, we are correct. We're acing this right now. So, I'm going to take a quick break and then come back and explain 3 more bitwise operators for you guys before I have to go. So, yeah, I'll see you then. and that'll be in like 2 seconds for you guys. But anyways, bye. Okay guys, I'm back, and so now I'm going to explain the bitwise operator called the bitwise not operator. And so you guys remember how earlier in the video I said that basically a bitwise operator takes two values, binary values, and turns it into something unique? Well, I kind of lied, because it doesn't necessarily require two values. So for this part of the tutorial, we are going to get completely rid of the number 3 and just use the number 2. And I'll change this to number 2. So basically what the bitwise not operator does is it basically inverts all of the ones and zeros in the number that it's given. So to use the bitwise not operator, you use the tilde key, which is the key right under the escape key, and just say number 1, like that. And then let me translate this for you guys. So basically, since this number is a 0, this one's a 1. Same goes for this, this, and since this one's a 1, this one's a 0, and the rest are 1. So basically, it's an inversion of the number that you are given. And I'm getting an error because I need a semicolon. Beginner's mistake right there. But I'm not a beginner, so anyways. So if I'm correct, our output should be that. And 10 hours later, there we go. So yay, once again we are correct, and this is our output. So okay, so now so I'm going to explain to you guys another bitwise operator. Actually, it's two more, but they're kind of the same thing. But anyways, what this thing is it is the left shift operator. And basically, here's what it does. So if I do num1 less than sign 2, basically it shifts. I'm gonna put these all to zeros. It shifts all of number 1's bits over 2 places. So this 1 will be over 2 spots this way. So it will be right there in our number 2. So basically it shifts all the ones over 2 spots. So let's run our program. And there we go. I think that's it. Yeah, that's the same number. So yep, we're right once again. And you guys might be wondering, okay, so I see these 2 less than signs right here, and I see 2 less than signs right here. But this is a function, and you're not trying to move all the bits in this function over by the binary value of this. I mean, like, that makes no sense at all. Well, that's because this is overloaded, guys, and that's used I can't talk, by using the operator. That was used in the programming for this function. So basically, when you use that operator thing, it is an overload function. But that's for a different video. So yeah, that's just to clear up some confusion that would probably be sparked by this, you know. Anyways, so, and then there's the right shift operator, which is the greater than sign, and that does the opposite of the left shift operator, go figure, and it moves all of the ones in the number above to the right 2 places. So this will be our output. And let's run our program. Here we go. So that is our output, and that is equivalent to this. So once again, we are correct. So that does it just about for this tutorial. If you guys need more explanation for what these bitwise operators are used for, I can make another video, but leave comments or something so that I know to make the other video. But anyways, have a nice day, and I'll see you guys next time.